I hope you're excited for the 26 questions interview.
I'm so excited.
So, what were you doing at this moment before we came by?
I was just cooking dinner for my dormmate.
So, are your dormmates home?
Well, Elijah's out to get some ingredients and she'll be back soon, but everyone's here.
What do you find yourself doing a lot these days?
Science?
Science, huh? So, who's your favorite scientist?
I really admire Galileo Galilei.
Do you have any favorite science topics in particular?
Well, I've been into gas laws these days.
Wow, could you show me around the dorm and show me applications of the gas laws seen here?
Sure, come on.
Cool. Now, what's your favorite beverage at the moment?
Just water. Look, a syringe.
Oh, which gas law does it apply to?
Boyle's law.
What is it about?
It's about pressure and volume.
Do they have this certain relationship?
Yes, they're inversely proportional. So when the pressure increases, the volume decreases.
Look what we have here. I have a Boyle's problem prepared, and would you mind solving it?
No problem. Wait, my timer's went off. Vasily, can you please answer this question first?
The volume of the air in a cylindrical container is 450 ml. The pressure is at 1 atmosphere. If the volume is at 50 ml, what will be the new pressure?
So, right here I have a marker and a board. So, may you please solve it for us?
Sure.
You have a minute.
Okay, so
It was said here that the volume of the container is 450 ml. So then we are looking for the final pressure and we were given 50 ml final volume. So P2 over times the 1 atmosphere pressure. So now to isolate the P2, you need to divide it by 50. So now pressure 2 is equal to 450 over 50, which is also equal to 9 atmosphere.
Wow, thank you. Now, where's Kay?
Come here. I'll take you upstairs.
Wow, exciting. So, as we go upstairs, I'm gonna ask you a few questions.
Sure.
What hobbies are you into right now?
Sports?
What kind of sports?
Maybe badminton?
Badminton? That's so
Yeah.
cool. Do you have any tournament you're involved in?
Not really.
Okay, shall we go outside?
Come.
What is he doing?
He's playing volleyball. Come here.
Since it was cold, my ball got deflated. Now I have to pump it again.
Yeah, it's the second application, the Charles law.
What is it about?
It's about the relationship of temperature and volume. And before you ask, they're directly proportional.
Yeah, like what happened to my ball. Since it was cold last night, the volume decreased.
Could you help me solve this?
Oh, what's this?
A gas in a container is at 27 degrees Celsius and has a volume of 4 liters. The gas is then heated to a temperature of 54 degrees Celsius. What is the new volume?
So here I have a marker and a board to help you solve.
So our formula will be V2, or the final volume, is equal to the initial volume multiplied to the final temperature over the initial temperature. We just have to substitute the values, which is 4 liters multiplied to the temperature, which is in Kelvin, so it's 327.15 Kelvin, all over 300.15 Kelvin. So our answer will be 4.36 liters, since our problem is looking for the final volume.
There you have it.
Wow, thank you. But Kay's gone again. I wonder where she is.
Come in.
What were you doing?
Just helping Rozelle out with the balloons for the party this weekend. And I think I found the third application.
Which one is it?
Avogadro's gas law. Avogadro gas law involves the number of moles and the volume, which are once again directly proportional. When I blow into the balloon with set of the gas inside the balloon, we can see that it expands. And when I release it like this, we can see that it deflates.
Oh, I guess it's your lucky day. Please solve this problem for me.
Okay, no problem.
Avogadro's law. At FTP, the volume of the gas container 1.32 mole is 475 ml. How many moles should the gas contain if it has a volume of 1.3 liters?
So here we have a board and a marker to help you solve. You have 1 minute.
First, know the formula of Avogadro's law, which is V1 over N1 is equal to V2 over N2. Then list down all the following. V1 is equal to 472 ml. N1 is equal to 1.32 mole. V2 is equal to 1.3 liters. And N2 is the one missing. And don't forget to convert the smaller one, which is 0.472 in liters. Then substitute all of this given into the formula. So 0.472 liters is all over 1.32 mole is equal to 1.3 liters all over missing.
Then we will arrive on the answer of 3.64 mole. And there we have it.
Thank you.
Come over here. I'm gonna take you downstairs to show you more stuff.
Wow, cool. No problem. Who's that on the door?
Must be Elijah with the groceries.
Does that mean everyone's home?
Yes, and dinner's about to start soon.
Doesn't it smell a little fishy around here?
Oh look! An air freshener. The fourth application, gay-lussac law.
Let me guess, is it about temperature and pressure?
You're right. So, when the pressure inside of this increases, it will later on explode.
That sounds a little scary, doesn't it?
Yeah, that's why aerosol cans like this have label on them that we should store it in a cool place.
Oh hey, that's mine.
While you were here, I think she has another problem on hand.
Yes, you're right.
So you have to solve it, okay?
Yeah, sure.
So, in the container with constant amount of gas and volume, the temperature of the gas is at 27 degrees Celsius and the pressure of 8.5 atmospheres. What would be the temperature in Kelvin if the pressure is at 21.3 atmosphere?
So here's a board and a marker to help you solve. You have a minute to solve it.
So,
Of course, we first need to list the formula for gay-lussac, which is P1 T1 equals P2 over T2. So our P1 here is 8.5 atm, and our T1, which is 27 degrees Celsius, when converted to Kelvin, is 300.15 Kelvin, equals P2, which is 21.3 atm, and T2, which is the unknown. So, in manipulating this equation, we would get this kind of formula. 300.15. So T2 is 21.3 atm times 300.15 Kelvin over 8.5 atm.
which will result into 752.14 Kelvin.
Wow, thank you. Oh, you're here.
Hi.
Heard you got ingredients. What did you get?
Just some canned goods because we ran out of those. Wait, I have to put this in the fridge.
Elijah, where are the... Oh, the last application.
The fridge? Ah, finally. What is it called?
The ideal gas law. It's a combination of all the gas laws with a constant.
What is the constant equivalent to?
0.0821 liter atmosphere over moles Kelvin.
Okay, Elijah,
Yes?
since you just came, you must solve this last problem.
Sure.
Radon is a rare, colorless, odorless, and radioactive gas. The scientists were able to gather 3.69 moles of the said gas. The gas was kept in a cylindrical container with a volume of 5 liters and in standard temperature. What is the pressure exerted of the radon gas on the walls of the container?
So here is a board and a marker that will help you solve for a minute.
Since the formula for the ideal gas is pressure times volume is equal to the moles times the gas constant times the temperature, we just have to manipulate it to get the pressure. And we get the moles times the gas constant times the temperature all over the volume. We just need to substitute it to get 3.69 times 0.0821 times 273.15 all over 5.
And we get 16.55 atmosphere.
Wow, thank you.
Elijah! Guys! The dinner's ready.
Okay, one last question.
Sure.
May I join you guys for dinner tonight?
Come on, let's go!